So hey, this is a video replacement on section 2.6. We're going to talk about continuity and differentiability. Now the differentiability part of this you've already sort of studied. It kind of came up in class a while ago like this. Can you imagine a function that you see like this? Now this is a function, that is, for every input, every x value, there is exactly one output. For instance, if I were to pick an input here, there would be an output that I could read off of that graph. And for every input, there is exactly just one output. What's interesting about this function is what's happening here at that sharp point. I said, that calculus is all about zooming in on curvy stuff until it looks straight. So I could zoom in here, for instance, and eventually what you would see would appear on, say, a screen on Desmos to just be a linear chunk. I could zoom in anywhere and it would look linear if you zoomed in, zoomed in, zoomed in, zoomed in enough. However, if you zoomed in up at that sharp point, this sharp point is known as a cusp. If you zoomed in on that cusp over and over and over and over and over again, you would not ever see what appeared to be a linear chunk. You would just continue to see that sharp point. So what we say is there is no slope of the curve at that cusp. There is no derivative at that cusp. The derivative does not exist, or the way we say it is, this function is not differentiable at x equals a. So differentiable is just the way we would communicate to somebody, hey, if somebody said, take the derivative, well, is the function differentiable? Which means, is this function one that can be taken the derivative of? And so we would say that yes, you could take the derivative at any point on this function except at that sharp point at x equals a. But let's look at it just one more way. Suppose you busted out the good old limit definition. Suppose you wanted to know the limit as h approaches 0 of there is the limit definition of function. But let's say we were going to consider the derivative of this function at x equals a. So we would evaluate this function at a plus a little bit. We would evaluate this function at a, and we would see what's happening. Now here's why this one brings up an issue. Can you imagine as h approaches 0, that is, you're going to go for a positive value for h, you're going to move just to the right of a smidge. So here would be your a plus h. Or let's just think about approaching h approaching 0 from the negative side. Let's say we went to this side of a just a little bit, that is a minus h. Kind of like that first day when Chloe and Jaden were talking about we can go ahead a little bit and behind a little bit. Imagine doing that. If you were to consider the slope of this curve just a little bit ahead of a, that is, if you looked at the function value here and here, the slope of the curve there would be very negative. If you did that same thing but you looked to the left of a just a little bit, that is, you found the slope of the curve between here and here, you would have a slope that is positive. Now we learned that in order for limits to exist, we'd have to get the same value from both sides. But the problem with this one is, depending on what side of a you are on, depending on if h was approaching 0 from the negative side or the positive side, we could get a slope that's really negative, or we could get a slope that's really positive. And since we would get two different limits, two different derivative values, we would say that this limit does not exist. Since this limit does not exist, the derivative cannot exist at that point. So two reasons: zoom, 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 zoom. Curvy stuff will never look straight at a sharp point like that. Reason number two, just to the left, slope is positive. Just to the right, slope is negative. And an instantaneous change between a and h, that little tiny window, we see two very different slopes, one that's negative and one that's positive. And so the limit does not exist, the derivative does not exist.